What's going on, everybody? This is Mr. Diamond, and today we're going to be working out two example problems, but I'm going to hide this one first because we're not going to go into that one just yet. These are going to be the notes / the examples for resolving a vector into its components. So our first example, our first vector that we're going to use is going to be 500 meters at 30 degrees north of east. Now, I've mentioned before, it's going to be a pretty good idea for you to actually have these things sketched out, so I really recommend doing that. I also like having multiple colors that I can work with, so I've got a couple of different colored pens I'm going to be switching throughout this video, so just as a warning, you may want to pause and go grab those if you like doing that kind of thing. So first, let's go ahead and draw our picture, because we always want to draw our picture. So I'm going to go ahead and do just a really simple, straightforward, very small coordinate plane. And then I'm going to take, and we'll use purple, and it says it's 500 meters at 30 degrees north, so north is this direction up here, so it's north of east. East is over here. So if we start from the east line, from this line that is east, we're going to go up from there, and this will be 30 degrees. And this will be 500 meters. So that just gives us an idea. I'm going to redraw this bigger down here. This is just to give us an idea of what we're looking at. So that's our question, and we want to resolve it into its components. We want to know what its two parts are. So to figure out its two parts, we're going to make this line, like I said, we're going to make it bigger. I'm going to move it down here. So this theta, which theta is just the symbol used in physics to represent an angle. Theta is 30 degrees. And then our vector here is 500 meters. Now, this vector is actually composed of two separate pieces. It has an x component going this direction here. And it's going to have a y component that's going to go this direction here. And so our goal is going to be to figure out what is our y component and what is our x component. That is what the question is asking when it's saying resolve it into its vector. So or a vector into its components. So how are we going to do that? Well, we're going to need some of our trig stuff. And just in case you've forgotten, you notice I may have left a gap up here. Your trig info or trig information we're going to need is the SOHCAHTOA. Don't worry, there's nothing new, there's nothing weird just because we're in physics. All of these work the same way. And the idea is that if you have an angle and if you have a right triangle, you can predict, and at least one of the sides, you can predict another one of the sides. So in this example right here, I'm going to pretend that my angle is down here. That's my theta. This would be the opposite. This would be the adjacent, and then the long side is always the hypotenuse. So what we're going to do here, we have an angle. We have our hypotenuse. We can just plug in and rearrange two separate equations to solve for each of our components of our vector. So I'm going to start with my x component. So I'm going to do that in the same color I did down here. So we're going to solve for x component. Our x component, we want to find the adjacent. We have the hypotenuse. So what angle involves the adjacent and the hypotenuse? That is going to be CAH. We're going to use CAH. So CAH means cosine theta is equal to adjacent over hypotenuse. So our theta in this case is 30. Our hypotenuse is 500. We're looking for our adjacent. We're going to rearrange this. So if we rearrange this pen's not doing the best job here, but don't worry, the next color should hopefully be a little bit better. We will get hypotenuse times cosine theta equals adjacent. And then we just plug in our information. 500 times cosine 30. I like putting my angle always at the very end just because I don't want to accidentally put this number into the parentheses on my calculator. So let's go ahead and we can just plug in our first piece. 500 times cosine of 30. We get as our number 433.0127019. Going back to the original question, 500 point has 3 sig figs, so we'll cut it off there. So it's 433 meters. And then this time it's going to just be positive. It's going to be a positive number because it's going to the right. We don't need to have an angle to describe it, and it's just moving to the right. So that is our x component. Now let's get our y component. So our y component, we want the opposite. And we have the hypotenuse, so we're going to use SOH. S-O-H. And the formula for that is sine of theta is equal to opposite over hypotenuse. Opposite over hypotenuse. We're trying to find opposite, so we're going to rearrange. If we rearrange, we get hypotenuse times sine theta equals opposite, which if we actually plug in our numbers, we'll get 500 times cosine, or sine this time, of 30. Thought I just heard the bell ring, so I was about to freak out and be irritated. My video was going to get ruined. So 500 times sine of 30. I am going to just, because it's basically the same numbers, I'm going to do second enter, and then I'm just going to back up and change this to sine. And now I got a clean looking 250. So we're just going to put a decimal at the end of that to make sure we know that it's got 3 sig figs. And it's going to be 250 meters. And that is our y component. Now, as a check, if you're paranoid that this isn't actually going to be working out, you can always plug in. Let me try to get it in the light so you can actually see it. You can take, and I'm going to go back and get this number. We're going to do the square root of that number squared plus 250 squared. And if you look at that, we do get 500. So this still is following Pythagorean's theorem. We are still ending up with the component like we wanted. Okay, I hope that makes sense. I think for this video, I'm going to try to separate each example into their own separate video. I'll upload it all in one place, but I think it'll be easier for you to be able to only watch one at a time and you don't have to commit to a full long video. So we're going to cut off this video here. I hope that makes sense. If you have any questions, please send me an email. Otherwise, have a great rest of your day.